A rectangular cube a rectangular cuboid has the following dimensions: length, width, and height, so much. Then it says calculate the length of AG. So from A to G. Now because it's a rectangular cuboid, all of these angles are at 90 degrees. All these lines are at 90 degrees. So we're going to use Pythagoras a lot here. So AG, because AG is actually going to be your hypotenuse, AG squared will be 0.8 squared plus 0.5 squared. And so AG is going to equal 0.8 squared plus 0.5 squared. And we actually take the square root of all of that. So we do that on our calculators. 0.8 squared plus 0.5 squared, 0.5 squared, enter, and then we take the square root of the answer. And you should get something like AG is equal to 0.94. Now we would do to two significant figures or two decimal places because we've got two decimal places here. So AG is equal to 0.94. Calculate the length of AF. So now we are looking at this over here. Now again, this line over here is going to make 90 degrees there. So we know that this is 1.8, and we've just worked out this is equal to 0.94. So we are going to find this one over here, AF squared is equal to 1.8 squared plus. Now I'm going to be, although I'm going to write here 0.94 squared, I've actually got this value in a more accurate form in my calculator, and I'm going to use that value. And then I'm going to obviously find AF by finding the square root of those. So take the value that I've got here. So I find my answer. I square it plus 1.8, and I square that, enter, and you get 4.13, and then you find the square root of that, and you get 2.03. So I'm going to put 2.0 meters would be this length over here from A to F, like that. Then it says find the size of the angle between AF and AG. So we're looking at this angle over here. So we've got a right angle triangle that we're going to be dealing with. We've got all three sides to it, so we can use any three. I'm going to use tan. This is opposite. This is adjacent, and I'm going to find this angle theta. So the tan of theta, which is equal to opposite of adjacent, 1.8 divided by 0.94. I put that into my calculator, 1.8 divided by 0.94, enter, and I get the tan of theta is equal to 1.91489. And then I'm going to, the buttons I'm going to push now are going to be second function, tan, second function, and I'm actually going to push this button over here, which gives me my answer, second function answer, and then enter. I'm going to push those four buttons there. So we push second, tan, second, gives me my answer. Actually, I need to close brackets after that also, probably to be good, and then you push enter, and I'm getting 1.809, and that's probably because my calculator is, the mode is in radians. I must just change my mode into degrees, and I go and do that, and I get enter, and I push clear. So I'm just going to do that again. We're going to find the second function of tan, and then I'm going to put here 1.9148, close brackets, enter, and I get 62.42. I get my theta. That angle is 62.42. Now I'm going to give my answer into two significant figures, so it'll be 62 degrees. I just want to show you about that radians thing. You need to make sure that with your calculator you've got it in radians. So if you go to mode here and you go down here, you must just check that you are in degrees here. So you put it on degrees, you push enter there, and then you clear and you go back to your. So make sure that you are in degrees when working with it.